Dear students, today our topic is about the momentum and impulse. That is, here in this lecture we will discuss what is the momentum and how it is related with the impulse. Okay, for many masses, that was about the single mass, but for we have the number of the masses, or we have the complex system of the masses, that is for many mass system. Then how we will write Newton's second law. So for many mass systems, Newton's second law can be written as, we can write the F. We can write the F like integral of F into t. That integral varies from t1 to t2, and this integral will be equal to the integration of, that is, time derivative of momentum dp by dt into t. So this will be equal to, so time derivative of force for many mass systems is equal to, that is, momentum of the particles at time t1 minus momentum of the particle at time t2. That is, it's just the momentum. It's the difference of the momentum with time. So we can write it like the difference of momentum delta p, and this will be equal to the integral f dt v1 to dt. So this integral has a special name, and special name for this integral is called as the impulse. So impulse means the sharp or weak force, the varying or shock, that is the force which is varying with the time, that is the impulse for a short time. So we can graph, so we can here make the graph of, that is the delta t, and that is the force, and along the y-axis, and it starts from the 0. So what will be the impulse? So here we have like this one. So impulse, we can measure the impulse as area under the curve. So that is the force that is varying with the at delta t, from 0 to delta t, and these are the small values. So it means that force is not constant, that it is varying with the time. So impulse can be represented by here the area under the curve. So now we can introduce and the concept of average force instead of varying force. So average force is the constant force. So by graphing, taking the force as a constant, we make the graph like this one. Again we can plot the graph of delta t and force. Now here the force is the constant, and we take the average force instead of varying force. So again we have the same area under the curve. So we can write over the average force like this one. So average force, F average, will be equal to the, again it's the integral from, now it's integral from 0 to delta t, that is study from 0 to delta t, and is equal to f of t dt. So I can rewrite it like the, our average force is equal to f average equal to 0 to, I can, okay, there is some problem, I can rewrite it like this one. So f average is like 0 to delta t f d t divided by delta t. So this one is our average force, and this one is our relation between the momentum and impulse. So this is the most general form of the moment of the Newton's second law, and we can use it for the many particle system instead of the Newton's second law like F is equal to ma, which is a special case of the Newton's second law which can only be used for the single particle. So here this form of the Newton's second law, that is impulse is equal to delta p, can be used for many applications for the momentum of many particles and for the complex systems. Thanks for watching. For more videos, please subscribe our channel.